Hey guys, this is Fraser with Links Point Tutoring. So today we're going to be looking at the 6-mark SL proof question. It also easily been in the HL, although the HL usually has some induction or contradiction questions. This is more of like a direct proof. So it's asking us to consider, it's 6 marks, 2 marks, and then 4 marks. So it's asking us to consider 3 consecutive integers, where the first one is n minus 1, the middle is n, and the next one is n plus 1, right? So it's going up each time by one number, so we know that they're consecutive integers. And it's asking to prove that the sum of these 3 integers, for some reason, the sum of these 3 integers is always divisible by 3, and then we have to prove that the sum of the squares of the 3 integers is never divisible by 3. So to begin with, we know that the sum of these integers is going to be n minus 1 plus n, plus n plus n plus 1. So n plus n plus n is 3. n minus 1 plus 1, so it's just 3n. Since n minus 1 plus n plus n plus 1 is equal to 3 times n, we know that the sum must be divisible by 3. So this is why it's a 2 marks, must be divisible by 3. Literally all you do is you just show the sum, you add them up, you show that it's 3 times some number, and by definition, if something is equal to 3 times some of the number, that means it must be divisible by 3. So that's why it's only 2 marks. Next part isn't too hard either, it's 4 marks. So prove that the sum of the squares. Okay, so now we take the squares, n minus 1 squared, and we add up all of the squares. So that's going to be n squared minus 2n plus 1 plus n squared plus n squared plus 2n plus 1. So again, this is going to equal 3n squared plus, and then minus 2n plus 2n. That's going to cancel. We have 1 plus 1, which is 2, which is equal to, I guess we could do 3 times n squared plus 1 minus 1. And obviously, right, I've just wrote it as 3 times something minus 1. So if it's 3 times some multiple minus 1, that definitely means that we cannot factor out a 3. So since we cannot factor out a 3, we know the sum of the squares cannot be divisible by 3. So proof, and that should be it. So proof is a little different to SL because you basically, there's quite a lot of writing, and HL as well actually, there's quite a lot of writing. So the actual algebra doesn't tend to be that challenging, but the understanding of what you have to write can sometimes be a little bit challenging because you're not quite sure what you have to say in order to prove it, right? But then again, that's why we're practicing. But there's quite a lot of writing in these kind of questions, so hopefully that was clear. I'll probably be doing more proof questions, especially direct proof, because they're not always as straightforward as the HL proofs, since those are quite formulaic. So I'll be doing more of these. Let me know if there's anything else you guys wanted to see. And as always, if you guys feel like you need a bit more tutoring, a bit more help with your studies, not just maths, but other subjects as well, feel free to head over to Links Point Tutoring. There are 2 links below, one international and one Dutch, since we're a Dutch company based in Amsterdam. And yeah, you can feel free to have a trial lesson. The tutors are very flexible. You can tell them when you can do lessons. They always have recommendations. But ultimately, it's up to you and your parents about what you guys would like to be, how you would like to be doing the tutoring, how often and when. So yeah, as always, I'll be making more of these videos. Have a great day, and I'll see you guys soon.